generalized coordinates. So as you can see, there are two terms which is generalized and also coordinates. So generalized means something which is general or which is flexible, right? So what do we mean by coordinates? Coordinates, what is the use? To find position or configuration, right? So from generalized coordinates, we can say the definition as, in simple terms, they are the variables used to find the position or configuration and by considering the constraints which already taken by Anushara. So the important definition which is, generalized coordinates are a set of independent parameters which is used for specifically finding position or configuration with respect to the reference of point or frame. Okay. So while moving to the mathematical representation, if a system has n degrees of freedom, we can completely find or explain the generalized coordinates. And we can say that in classical mechanics, a particle, we are mainly using the Cartesian coordinate system in 3D. So while taking the Cartesian coordinate system in 3D, there will be 3 coordinates, x, y and z. And by taking the constraints, we can say the generalized coordinates, we can write it as qi is equal to q1, q2, q3 etc. up to qn, where we can say the qi term is known as generalized coordinates, where n is the degrees of freedom, number of degrees of freedom. And from here we can say that each coordinate system there will be one possible independent parameter to find the motion or position or configuration. And also the important point is, number of generalized coordinates equal to number of degrees of freedom. Suppose we are taking one particle which is in space. So there will be 3 coordinates, right? For its space x, y, z. So for one particle x1, y1 and z1. And for another particle there will be x2, y2 and z2. So what will be the degree of freedom for 2 particles? These are 2 particles. So what will be the degrees of freedom? 3n, right? So we can find the degrees of freedom as 3n, where n is the number of particles. Here there are 2 particles. So for 3n, here n is 2. So it will be 3 into 2, which is 6. These are the degrees of freedom. And also, how can we find the generalized coordinates? As the definition says that generalized coordinates are the independent parameter or variable used to find the position or configuration. Here there are 1, 2, 3. 3 from here and also 3 from here. So 3 plus 3, 6 generalized coordinates, which are 6 independent parameter used to find the position or configuration is there. So we can say that these generalized coordinates, number of generalized coordinates equal to the number of degrees of freedom. Are you clear? The properties, we can see the examples which include simple pendulum, double pendulum, particle moving on a circle, particle on a sphere and mass on a spring. So today I am going to talk to you about 3 examples which are simple pendulum, particle moving on a circle and particle on a sphere. So first we can see the particle moving on a circle. Suppose one particle is moving in this part and there will be one fixed radius, right? It will be always fixed and it will be in a plane, right? When the particle is moving on a circular path, it will be in plane. So it will have how many coordinates? 2 coordinates, x and y. So x and y. And what is the relation between x, y and r when particle is moving on a circle?
X square equal to r square.
X square plus y square
Equal to r square.
equal to
R square.
r square. Suppose here there are two coordinates, right? So if we are taking x as independent variable, y will be the dependent, because if the x is known, we can find the y from this relation. Suppose if x is known, so we have to find the y square. How can we find the y square? R square minus x square. So here we can find the one independent variable which is x and one dependent variable which is y. So and also we can see the generalized coordinates will be equal to x, because we can find, if we are taking the x as independent, we can find the y term from using this relation. So there will be only one independent variable. Now this is in Cartesian coordinate system. If we are moving to the polar coordinate system, suppose the particle moving on. Okay, now we have seen the Cartesian coordinate system. If we are taking the polar coordinate system, if suppose the particle is moving, there is one radius, right? And there will be one angle, because it's a polar coordinate. So there will be terms like r and theta. So if you are taking r and theta by moving it in a polar coordinate or a circle, here r will be fixed, right? Moving on a circle means the radius will be fixed. So the only independent variable here which is theta. So the generalized coordinate will be theta. The only generalized coordinate or the independent variable which is used for finding the position or concentration is theta. Is it clear? Simple pendulum. So in the part of simple pendulum, here there will be it is also in the plane coordinate, right? So it is having two coordinates, which is x and y. So here this is x coordinate and here it is y coordinate. And suppose L will be the length of the pendulum. And here there is also we can find the relation as x square plus y square equal to L square. So compared to the previous section, we can find that if x is the independent parameter, we can find the y from this relation as L square minus x square. So the independent parameter will be x and the dependent parameter will be y. Is it okay? So here the only independent parameter is x. Okay. So in the case of polar coordinate, if we are saying that the simple pendulum is moving, which is having a length L and moving in an angle of theta, we can say that L will be, the length of the pendulum will be fixed throughout the motion. So the only independent variable here is theta. So here also the generalized coordinate will be theta. Okay. Now let's move to the particle moving on a sphere. For a sphere, how many coordinates will be there? It will be space, right? So three coordinates, which are x, y, and z coordinates. Suppose a particle is moving in a sphere. So as I told you, it will have a radius r and the coordinate as x, y, and z. So there is also a relation which is x square plus y square plus z square equal to r square. Can you say if it is only one independent variable? By looking at the previous section and here, there will be not one, right? There will be two, because from x and y we can say they are the independent variable, because we can find the z term from using this term. So the z square will be r square minus complete position or configuration of system, we can find it through the terms like x and y coordinate. Okay, so comparing to the properties, so generalized coordinates not completely mean that they are only constrained to Cartesian coordinate system, because we have seen the polar coordinate system, right, which includes r and theta. So the first property is generalized means they are generalized coordinate means they are not necessarily in Cartesian. We can also use the polar coordinate system, spherical coordinate system, and also cylindrical coordinate system. And the second one is not even inertial. What do you mean by inertial? The body which will obey the Newton's first law of motion. They are called inertial, and which will be not obeying the Newton's first law is known as non-inertial. So it is not even in the inertial. It can be in also non-inertial frames. And the third one is must be independent and complete. So generalized coordinate must be independent, and also it should explain about the complete system of particles. It should not always be some particular. It should completely explain the whole system of particles. And the space spanned by the generalized coordinate is known as configuration space. Suppose we are taking one particle in space called x1, y1, z1 and x2, y2, z2. Previously I told that there are 6 generalized coordinates, and from this generalized coordinates it have to be in a space which is arranged in a space. That space is known as configuration space. So if it is x1, y1, z1 and x2, y2, z2, we have to make it, or it have to be arranged in a particular space called configuration space. And also it should have to be this whole axis, it have to be arranged not particularly, it have to be arranged particularly at some point, and it should be explaining about the whole system of particles. Okay, so these space which are arranged by the space spanned by the generalized coordinate is known as configuration space. And what are by talking about the examples, I already told you the cases of simple pendulum, particle on moving on a circle, and also particle on sphere. So there are generalized coordinates. And in the first slide, I have told you that the number of generalized coordinates is equal to number of degrees of freedom. So from that, you can see that number of generalized coordinates is equal to the number of degrees